Hi again. So today we're talking about systems of linear equations through elimination. So think about the word eliminating. You're getting rid of something, and that's exactly what we're doing for these problems. We either want to get rid of the x values or the y values so that way we can solve for x and then plug it back in, or substitute it back in, I should say, and solve for y. So if you look at the equations, first of all, everything has to be lined up. The x's are lined up, the y's are lined up, the equal signs, and the constants. Now, it doesn't necessarily have to always be in that order. It could have been y equal sign x constant. But as long as everything is in the same order, from the first equation to the second equation, then we're good. Now, if you can add straight down and eliminate an x or a y, then you don't have to do anything else to the equations before we start. So, looking at the y's, if you add a positive 2y with a negative 2y, they cancel out. Alright, so we're going to just add straight down. Well, negative 6x plus another x, technically there's a 1 there, becomes a negative 5x. Those cancel. Equals negative 16 plus 11 gives you a negative 5. Well, we want to get x by itself, so we have to go backwards and divide by negative 5. Okay, so x equals 1, and then our last step is to plug 1 back into our equation and solve for y. It does not matter which equation you plug it back into. So let's do the second equation. So we're going to put parentheses around the 1. In this case, it didn't make a difference, but you should get into the habit of writing down parentheses or drawing parentheses around what you plug in. Okay, so we want to get y by itself. We need to get rid of that 1 by subtracting it on each side. Everything else is brought down. 11 minus 1 is 10. Last step, divide by the negative 2 because once again we're going backwards. And y equals negative 5. So our final step is to put this into a coordinate pair. So once again x's come before y's. So 1, negative 5. And here is our final answer, or the solution, which is where they intersect. Now, I'm just going to have 2 examples for today. If you're bummed out, you can always get more examples. But our second example for today, again, we either want to get rid of the x's or the y's. Now, notice that the x's are lined up, the y's, the equal signs, and then just the constants. Well, if we add straight down, we're not eliminating anything this time, because 8x plus a negative 4x, we're left with 4x. 9y plus a negative y, we're left with 8y. And negative 1 plus 25, well, that gives us 24. So that didn't really help us. I'm actually going to erase that because it didn't get us any further. Okay. Well, we have to do something with either the top equation or the bottom equation, or both, so that either the x's or the y's cancel out. So, for example, if we want to get rid of the x's, what would eliminate a positive 8x? It would be a negative 8x. So what can I do to a negative 4 to make it negative 8? We can multiply it by 2. So everything across would be multiplied by 2. Alright, so 2 times a negative 4x gives us negative 8x. 2 times a negative y gives us negative 2y. And 2 times 25 gives us 50. Well, we didn't have to do anything to the top equation because, look, we now have 8x. That's going to cancel out with a negative 8x. So I'm just going to take this equation and I'm going to write it below, if I can get the pen to write where I want it to. I'm not changing anything, just writing it below. So if we add straight down, well, those x's go away. Negative 2y plus 9y gives us 7y. 50 plus negative 1 gives us 49. And we can go backwards to get y by itself by dividing by 7, since we were multiplying that by 7. Well, 49 divided by 7 is 7. So our last step is to go back and plug it in for y. So once again, it doesn't matter which equation. I'm going to plug it into the top one this time. But I could have plugged it into the bottom one. Again, does not matter. 8x stays the same. Now, since we're plugging in 7 for y, we have to put parentheses around the 7. Otherwise, it looks like 97, and that's very different from what it really should be. 9 times 7 is 63. Everything else comes down. We want to get rid of 63, so we're going to go backwards. So 8x equals, well, negative 64. Last step is to divide by 8. And 64 divided by 8 is 8, and a negative divided by a positive is a negative. So we have our x and our y values. Once again, our last step is to put it into a coordinate pair, because this is the point where they cross. So negative 8, 7 is our solution. It's where they intersect. If you have any questions, once again, come to your teacher, ask him or her at the beginning of class, or during resource if you need a little bit more help than that. So thank you for your time, and we'll see you tomorrow in class.